Hi everyone, I'm Runnu and today I'm going to explain the NSEM question paper of data science. So without wasting time, let's get started. So the first question is crisp DM, real world problem. Take a real world problem and explain how each crisp DM phase would be applied to address this problem. Include at least one specific task under each phase. So the answer for this is a telecommunication company wants to predict which customers are likely to cancel their service to take proactive retention action. First, business understanding task. Define churn example service cancellation within 30 days and set a business goal example reduce churn by 10%. Data understanding. Collect data from various sources, customer demographics, usage logs, billing history, and perform exploratory data analysis to identify initial patterns. Data preparation. Clean the data by handling missing values, removing duplicates, and creating new features like average monthly usage or tenure in months. Modeling. Select and apply modeling techniques such as logistic regression or random forest to build a predictive model, split data into training and testing sets. Evaluation. Assess the model's performance using metrics like accuracy, precision, recall, and ROC-OC score to ensure it meets business objective. Deployment. Integrate the final model into the company's CRM system to generate a daily list of high the marketing team to contact. Next question. That is first question B part. Type of data. Differentiate between structured, unstructured, and semi-structured data with suitable real-world example. So here is structured, unstructured, and semi-structured data types. Description of structured data type. Highly organized and formatted, typically used in stored in relational databases, RDBMS. It has a predefined data model and schema. Real world example. A customer transaction table in a bank's database with column for date, amount, account ID, and transaction type. Unstructured data. Data that has no predefined format or structure, making it difficult to collect, process, and analyze using traditional methods. For example, social media posts, emails, images, audios, recording, video files, and PDF document. Semi-structured data. Data that doesn't reside in a relational database but has some organizational properties such as tags or markers to separate semantic elements. XML files used for data exchange or JSON. Second question, Bayes theorem algorithm. Demonstrate an algorithm that uses Bayes theorem to solve a small example where prior probabilities and likelihood are given. Answer. Neighbor classifier example. Classify an email as spam or not spam based on the presence of a word free given prior probability p spam given p not spam likelihood p free spam upon spam is equal story 0. And free not spam 0.1. Goal calculate p spam free using Bayes theorem. Here is the formula. We will calculate, everything is given above, and we will calculate this, and conclusion is since p spam free is approximately 0.842 is greater than p not spam free, which is this, the email is classified as spam. Next question. Probability distribution. Compare the binomial normal and Poisson distribution in terms of their assumptions and application. Answer. Here is the difference between binomial, normal, and Poisson distributions. So, assumption and application. Fixed number of independent trials, only two possible outcomes, success, failure, constant probability of success, P, and continuous data. And applications are quality control, number of heads in 10 coin flips, predicting election result, win-loss, modeling physical characterizing, height, weight, blood pressure. Normal, symmetric bell-shaped curve defined by mean and standard deviation. When an independent random factor contribute to the outcome. Errors in measure, standardize, test score, number of email received per hour, and Poisson distribution count the number of events in a fixed interval of time or space. Event occurred independently at a constant average rate. Number of customer, number of traffic cars enrolled in a year. Third question, data wrangling. Explain the data wrangling process with a suitable example. So here is the data wrangling process. Data wrangling or data mugging is the process of cleaning, transforming, and mapping data from one raw format into another format with the intent of making it more appropriate and valuable for a variety of downstream purposes such as analytics. Step gathering, collecting data from various sources, assessment, inspecting data for quality issue, cleaning, fixing error, handling missing data, remove duplicate, transformation, changing data format, creating new feature, aggregating, storing, saving the processed data for analysis. Example, raw data wrangling is raw data. You have customer data in a messy Excel spreadsheet with inconsistent data format and sales data in SQL database. Wrangling, you write a script to read both sources, standardize all dates to YYYMMDD format, merge the two datasets based on customer ID, handle missing zip code by imputing the most common one, and new column for total spend. Result is a single clean and structured data set ready for analysis. Next question, data cleaning, error and imputation. What are the data errors and artifacts in data cleaning? Explain any two imputation techniques. So the answer is data error and imputation technique. Data error and artifacts, these are inaccuracies and anomalies in data that must be addressed during cleaning. Missing value, empty or null cell in the dataset, outlier, data point that are significantly different from other observation, duplicate records, identically rows that appear more than once, inconsistent format, example date as this and this, typos and spelling errors, example CA, Calif, California. Imputation techniques to handle missing value, mean mode, mean median imputation, and k nearest neighbor, KNN imputation. And here is the process of doing it. Next question is a feature engineering techniques. Explain any four common feature engineering techniques for continuous or categorical data. So, common feature engineering technique: one, hot encoding, label encoding, scaling, normalization, binning, discretization. In one hot encoding, convert a categorical variable with n categories into n binary variable. Example, a color column with values red blue becomes two column is red and is blue. Label encoding assigns a unique integer to each category in a variable. Example, low, medium, high are encoded as 0, 1, 2 is suitable for ordinal data. Scaling, normalization, continuous. Rescale continuous feature to a standard range. Example, 0 to 1 for min-max scaling, or to have a mean of 0 and a standard deviation of 1. Z-score normalization. This prevent feature with larger magnitude from dominating the model. Binning discretization continuous. Converts continuous numerical variable into discrete categorical bins or intervals. Example, grouping ages into bins like 0 to 18, 19 to 35, 35 to 60, and 60 plus. This can help handle outliers and nonlinear relationships. Next question is measures of central tendency dispersion. For the dataset, this compute mean, mode, median, and standard deviation. Explain when to use each measure. And here is the formulas. Dataset is given, mean कैसे calculate करते हैं, सारी values को add on करके upon number, total number of value, we will get the mean, median. The mid value is called median. Mode is the value that appears twice, and standard deviation is calculated by this formula. Next question. Distinguish model and learning type. Distinguish parametric and versus non-parametric models, supervised versus unsupervised learning. So, parametric versus non-parametric. Parametric assume a fixed functional form for the data distribution. Example, a straight line. They have a fixed number of parameters to learn regardless of the data size. Example, linear regression, logistic regression. Pros and cons. Simpler, faster to train, requires less data but can have high bias if the assumption is wrong. Non-parametric models do not make strong assumption about the data's functional form. The number of parameter can grow with the size of data. Example, KNN decision tree support, vector machine, RVF kernel. Pros and cons, flexible, can model complex patterns but requires more data and is slower to train. Supervised versus unsupervised. Supervised learning. The model learns from labeled dataset which includes both input feature and the corresponding correct output target. The goal is to map input to output to predict future instances. Example, classification, regression. Unsupervised learning, the model learns from the unlabeled dataset. There are no predefined output category. The goal is to discover hidden pattern structure and grouping within the data. Example, clustering, dimensionality, reduction. Next is text mining metric. With reference to text mining, describe accuracy, precision, recall, F1 score, and illustrate their computation using a confused matrix. Classification matrix and confusion matrix. Confusion matrix is a table used to evaluate the performance of classification model. Here is the table. And accuracy, the proportion of correctly classified instance among all instances. This is the formula. Precision, the proportion of correctly predicted positive instant among all instances predicted as positive. Here is the formula. Recall sensitivity, the proportion of correctly predicted positive instances among all actual positive instances. Here is the formula. F1 score, the harmonic mean of precision and recall. It provides a single score that balances both, which is used when classes are imbalanced, and this is the formula. Next question is handling missing value. How are missing values handled? Suggest three approach. And missing value can lead to biased estimate and reduce the statistical power of the model. Here are three common approaches: deletion, imputation, and prediction model. Deletion, letter-wise deletion, remove entire row that contain any missing values. Pairwise deletion, use all available data for each specific analysis, dropping only the missing values for the variable involved in that analysis. Usage best when the missing data is minimal and is missing completely at random. Imputation filling in. Replace missing value with a substitute value. Simple imputation and advanced imputation. Prediction model. Treat the column with missing values as the target variable and the continuous data classification for categorical data on the row with complete data to predict the value of the row with missing data. Next question. That is logistic regression. Explain logistic regression and use the logistic function to calculate probability of a class for a given input. Logistic regression and logistic function. Logistic regression is a supervised learning algorithm used for binary classification problem. Example yes, no, true, false, 0, 1. Unlike linear regression which predicts a continuous value, logistic regression predicts the probability that an instant belongs to the particular class, usually class 1. It uses the logistic sigmoid function to map the output of the linear equation z is equals to the given equation to a value between 0 and 1. Logistic function is given where z is the linear combination of input and weights and e is the Euler's number. Calculation, and here is the example, let the linear equation bz is equals to 2.5 for the given input, and this is calculated. Now, seventh question is k-mean clustering. Explain the k-mean clustering algorithm with steps. Discuss how initial centroid influence results. K-mean algorithm and initialization. K-mean is an unsupervised algorithm that partition a dataset into k distinct non-overlapping clusters. Algorithm step: choose k, select the number of cluster. Initialization: randomly select k data points as the initial cluster centroid. Assignment: for each data point, calculate its distance to each centroid and assign it to the closest cluster. Update: recalculate the centroid of each cluster by taking the mean of all data points assigned to that cluster. Repeat step 3 to 4 times until convergence is reached. Influence of initial centroid. K-mean is sensitive to the initial placement of centroid. A poor random initialization can lead the algorithm to get stuck in the local minimum resulting in suboptimal clusters. Different initialization can lead to different final clustering results. Solution: technique like k-mean plus provide a smart way to initialize centroid. Next question is clustering and KNN example. Completely demonstrate the clustering algorithm and compute a KNN classification example using Euclidean distance. And here is the given example for both of them, k-mean and KNN demonstration. So this is all mathematics. Points, initialization, iteration, then iteration, update, then KNN, label data, new point, calculate Euclidean distance. This is the formula. Find nearest neighbor, 3 nearest neighbor, classes and neighbors, majority vote, prediction. Now the eighth question is assemble method comparison. Compare decision tree, random forest, boosting, highlighting strength and weakness of each. And this is the difference between decision tree, a single tree like a model, like that split data based on feature value to make prediction. Simple to understand, interpret, handle both numerical, categorical data required, little data preparation. Phone prone to overfitting, leading to poor generalization, sensitive to small changes in data. Random forest, an assemble method that builds many decision tree on random subset of data and features and averages predictions. Reduces overfitting and variance, leading to higher accuracy, robust to noise and outlier, provide feature importance, less interpretable than a single tree, slower to train and predict due to multiple trees, then boosting an assemble method that build tree consequently. Each new tree attempts to correct the errors of the previous ones, often achieves higher accuracy than random forest, reduces both bias variance. And here is the weakness. Now next question is logic gates with neural network show how basic logic gates can be built using single layer neural network. So here is the table for and not gate and note on XOR and back propagation. The XOR gate is not linearly separatable and cannot be implemented with a single layer perception. It requires a multiple layer network, at least one hidden layer. Backpropagation is a training algorithm used for multi-layer neural network to update weight by propagating the error backward. It is not needed for fixed weight single layer perceptron implementing basic gates. Now ninth question is information gain calculation. Consider the following sample dataset. Calculate information gain for age, income, student, credit rating, find which attribute gives the best first slip. And for this question there was a table in question paper and this is the solution for that table. So next question is Gini index calculation and tree building. Calculate Gini index for all attribute. Question 9a. Find the best first split and then build the complete decision tree. And the Gini index was calculated here. So have a look about it. Now let's move to the last question, that is compare decision tree. Draw two decision tree, one from information gain, one from Gini index, then compare the final rules from the both trees. And these are two different trees and the final rules are here. Thank you for watching. This concludes the solution review for IC 502C means data science. Wishing you all the best for your semester result. Thank you.